Hey everyone, and welcome! Today, we're going to pull back the curtain on one of the most important, yet kind of invisible things that powers our digital world, the database. So let's jump right in.
I mean, have you ever really thought about it? It feels like magic, right? You type one letter into your contacts and boom, the right person just appears. Or how does your bank know your exact balance in like a split second? Well, the answer isn't magic. It's an incredibly well-organized system working behind the scenes. And at its heart, a database is really just that simple. The best way to think about it is like the ultimate digital filing cabinet. But instead of messy paper folders, it stores all kinds of information in a way that makes it super easy and crazy fast to find, update, and manage. It's really the foundation of all digital organization. And trust me, they are literally everywhere. The records your school keeps, all the details your bank has for your account, your doctor's patient files, and yep, that contact list on your phone. Every single one of those lives inside a database. They are the silent workhorses of our modern lives.
Okay, but not all filing cabinets are built the same, right? I mean, depending on what you need to store, you might use a different kind of system. The exact same thing is true for databases. So let's take a look at the two main flavors. So the two big categories are relational, you might hear people call these SQL databases, and non-relational, or no SQL. Relational databases are kind of like spreadsheets on steroids. They use these really neat structured tables with rows and columns. It's the classic old school approach. Non-relational databases are way more flexible. I mean, imagine trying to cram a tweet, a photo, a video, and a poll all into the same rigid spreadsheet. It would be a mess. It just doesn't work. And that's why NoSQL is perfect for all the complex, messy, ever-changing data we have in modern apps. And this table here gives us some perfect real-world examples. You can see relational databases are the go-to for things that have a super clear structure, like school records or bank transactions. But on the other hand, non-relational databases are what power the really dynamic world of social media feeds and mobile apps, where the data is just way less predictable. All right, so if it's a digital filing cabinet, what's actually inside it? What are the tools that make the whole thing work? Let's take a little look at the anatomy of a database. Well, first up, every good filing system needs a manager, or maybe a librarian, right? For databases, that's the DBMS, which stands for Database Management System. It's the essential piece of software that lets you actually talk to the database. You use it to create it, add data, ask it questions, and keep it all secure. Honestly, without a DBMS, a database is just a useless pile of data. And I bet you've probably heard some of these names before, even if you weren't totally sure what they were. Microsoft Access, MySQL, Oracle, these are all really popular examples of database management systems. Each one is a super powerful tool just designed to manage data for different needs and different scales. Now, this slide is super cool because it shows the whole workflow. So, the data itself, like student marks, lives in something called a table. Then, a teacher would use a form to make it easy to enter new marks. To find specific information like, hey, which students got an A, you run a query. And finally, to present that information all nice and clean, you create a report, like a printed out results sheet. Table, form, query, report. Those are the big four.
Okay, this is where the real power of relational databases kicks in. It's not just about storing data in tables, it's about intelligently connecting those tables together. Let's dig into how that actually works. So why even bother with all these connections, or relationships as they're called? Well, the whole point is to keep your data clean and efficient. Instead of typing out a student's full name and address every single time they sign up for a new class, you just link their main student record to that class. This cuts down on errors and saves a ton of space.
So how do we make these links? We use keys. First up is the primary key. This is basically a unique identifier for every single row in a table. Think of it like a social security number or a student ID. No two students can have the same one, and it can never be blank. It's the unique anchor for that specific piece of data. And if the primary key is the anchor, the foreign key is the bridge that connects everything. So if the student ID is the primary key in the main students table, well, when you put that same student ID in the class enrollment table, you create a link. That student ID field in the enrollment table is now the foreign key. It refers back to that unique student record, connecting the two tables. Pretty clever, right? So these keys let us create a few different types of relationships. The simplest one is called a one-to-one. Just think of it this way. For every one student in the database, there is exactly one unique school ID card. It's a direct, exclusive link. Simple as that. Next, we have the one you'll see all the time, a one-to-many relationship. This one's the real workhorse. One teacher can have many students. One class has many students. One author can write many books. It lets one item in a table be linked to a whole bunch of items in another.
And finally, we get to the most complex one, the many-to-many relationship. Think about it. Many students can enroll in many different subjects, and, at the same time, many subjects can be taken by many different students. To handle all that complexity, databases use a special linking table that sits in the middle and just keeps track of all those crisscrossing connections. So after all that, tables, keys, relationships, you might be asking, okay, but why does any of this really matter? Well, it's because this isn't just some abstract theory. This stuff is the invisible backbone that supports our entire digital life. So let's just do a quick recap of the big takeaways. At their core, databases are just really organized digital filing cabinets. They come in two main flavors, the structured table-based kind and the flexible kind. They're all managed by a piece of software called a DBMS, but their real secret sauce is using keys and relationships to link all our data together, which keeps it accurate and super efficient.
You know, I love this quote because it just sums it all up perfectly. The whole goal of all this structure, all these cables and keys and rules, is just about speed and reliability. It's about finding exactly what you're looking for instantly. Seriously, from the simplest app on your phone to the most complex global financial systems, everything runs on these principles. They are the fundamental building blocks of the information age. So the only question left is, now that you know how they work, what are you going to build with them? Thanks for joining me.